15.59. Methane reacts with iodine, and then it makes methyl iodide right here. And then it tells us it's got a K that's equal to 2.26 times 10 to the negative fourth. And then it says that the partial pressures were 105.1 initially and 97.96 for iodine initially. We're assuming that there's none of the CH3I to begin with. Now it says calculate the pressures and torque for all reactants and products at equilibrium. And so when this establishes an equilibrium, we lose X amount of this, we lose X amount of this, and we gain X amount of this. And at equilibrium, we end up with 105.1 minus X, 7.96 minus X, and we end up with X amount of this. Now to solve for K, K would be equal to the products, CH3I, to the first power, divided by reactants, CH4 times I2. And then we'd put in these numbers. So on the top, we'd have X, and on the bottom, we'd have 105.1 minus X, and we'd have 7.96 minus X, and this would be equal to 2.26 times 10 to the negative fourth, which is our K value right here. Now we have some FOILing to do, because we have to do first times the outers times the inners and then times the lasts as well, and get all of those values put together. And once we do all of those values together, then we will get our equation of, I'll write it out, 0.999774x squared plus 0.02555x minus 0.18907, and that's after I did all the algebra to set it equal to 0. So all this FOIL and term gathering equal this. Now on a testing situation, you just have to be able to do this and then write, I would now solve for X. But I'll show you the quadratic formula here. It would just be negative b plus or minus the square root of b squared minus 4ac all over 2a, and then eventually once you solve for that you get x equaling 0.422 torr. There's also a negative solution that you get, but the negative solution is not chemically meaningful, and so just look for the positive one because you're not going to end up with a negative amount of substance, in this case of pressure. And so then at equilibrium, the pressure of CH3I is going to equal X, which is 0.422. The pressure of the CH4 would be equal to 105.1 minus the 0.422, which would end up being 104.7, and the pressure of the iodine at the end would be the 7.96 minus this 0.422, which is 7.54 torrs. That's everything with a quadratic equation. Good luck.